and boom, and boom. So we're gonna teach you how to annotate this stuff. So the problem is, some people see the graph. Did you guys see a graph as a straight line? So that's because you guys don't read certain things. So I'm going to talk about the calculator part, like what things to emphasize. Like in terms of calculator, make sure that you see, if you see something straight line or something, see nothing on the graph, mostly likely your domain is set it wrongly. So the things you should read is this part, is this domain right here. And this is the equation. And it's given by two functions. It's greater than 300, then it's going to be 0. It's less than 300, it's going to be this. So those are the things that you should pay attention to. Of course, this is the initial condition. And R of t is this one. And exiting the line at a constant rate of 0.75 seconds per things. So they say, so first question doesn't include an initial condition because they say how many people entering on a line. So it's a little bit different than how many people is in the line. So those are the things that you should consider. So first question, you should be very easily. So how do you set it up on AP exam? You cannot just write the answers at 270. You have to write down says 0 to 300 of RT dt. Now some people says, do I have to write down RT? No, you don't, because they already have RT up there, and that's equal to 270 people. For B, the way I did it is different than Jackie's way. So what I would do is, they say this one says how many people entering line 300 to 300. They say 300 times there are always people in the line escalator. How many people are in the line at t equal to 300? So think about this as an escalator, and start with the 20, right? 20 people is in there at the very beginning, so you should have 20. Plus, there are some people that's coming in. There's some people that's coming in, and then some people is leaving. And coming in is RT, leaving is 0.7. Now they both have velocity, they both have rate. So if you integrate of rate, it's gonna get amount. So the integrated velocity equal to distance traveled. Integrate of rate of coming in is gonna be amount. Well, I'm gonna integrate between 0 to 300. And I'm gonna say RT. And I'll say, well, I'm gonna take away the leaving part, which is minus 0.7 dt. Now, why it's not 0.7 t? Because you integrate that, you're gonna get 0.7 t, and that's what Jackie did, is integrate that, and you got 0.7 t times 300. But for me, that if you do this part, you should get enough answers, so it's gonna be 80 people. So it's called net rate. Net rate is whatever comes in, subtract whatever is out. So net rate, so in rate minus out rate. Okay, so that's equal to net rate. So in rate minus out rate. So C, they say, well, what is the first time when there's nobody in the line? Well, what happened at 300 seconds? There was 80 people, right? Well, first of all, there was 300 seconds, first of all, plus 80 divided by 0.7. Why? Because you got 80 people, and this is people, and you got 0.7 people per second. So if you cancel this out, it's going to be seconds. So it'll be 300 plus 114.268, I think. So it'll be 3. So it's 414.268. So that's the amount. Now, the last part is really difficult to understand. But this is last part is the only part I really need you to understand that. So if you think about that, You say how many time what is the time t of number of people in the line minimum to the nearest whole number? Find the number of people in the line in a time. Justify your answer. Now, when I justify it like this, it must means there was some type of table. So this is people. There's a t people. Obviously, we know 0 is 20. At 300 seconds is 80. Can it be possible answer? Obviously. Now, way I kind of think about this. You got something that is coming in, right? And there was something leaving. The maximum minimum happen if they both in and minus out is exactly equal to each other. The one way kind of think about it, think about you fill in the water here. Like you start fill in, right? You start filling the water. Water's blue, hopefully. And you start filling the water. And if you have 20, you start filling. But you also have something leaking inside the thing. When they reach maximum is, at first you probably have the greater in rate and there was a minor out rate. But when they reach maximum is when the in rate is equal to out rate. Does that make sense? Otherwise, they don't go any further up anymore, and they don't go further down because it's just if you keep on adding water in the water bottle and something's leaking, if in minus out when they're equal to each other, that's where water's gonna stop filling. Does that make sense? And same thing as you going down, the same way. It's leaking more than out, then it's start going down, right? Now when you're going down, now if I find a way to put in more water than in, put the same amount of water in and out, then it's gonna stop. It's gonna create a minimum. So therefore, is the net rate equal to 0? So D is net equal to 0. Well, how do you do net equal to 0? That means RT minus 0.7 equal to 0. Now, why are you doing that? If you have RT minus 7 is equal to 0, it's going to give you a, when the rate becomes 0. When the rate becomes 0, it's going to create two situations. Are they a maximum? Are they a minimum? So what we're going to do, we're going to use a TI inspired calculator. I know none of you guys have this calculator, but it's going to work exact same way. If you don't understand, just ask me. So what I'm going to do is I'm going to graph here. Sorry, I am going to graph. Where's my graph? This is my graph. Well, hold on a second. I can't go to graph, so I guess I'm going to create a new menu. New graph. Dark. Maybe this part. Maybe this part. Okay. So I'm going to do a tab. Okay. So I'm going to create a function. So at first, if I create a function, I'm going to go up to this one and I'm going to press enter. I'm going to graph it. So graph is going to come out to be something like this. And this is the graph. Now, why I see this and you don't? Okay. Why I see this, you don't. So first of all, I'm going to go into put a tab and I'm going to go to 2. That doesn't make sense. Why is this one's f1 of x? You know what? Let me just restart the graphing. New. So I'm gonna graphing from scratch. So I'm gonna do graph. Wait, how do I get rid of this graph? Maybe new. Do you want to save? No. So I'm gonna add a graph here. So I'm gonna type in the function. And how I type in function is gonna, can somebody tell me the function? Okay, now I can see 44 parenthesis, wait, 44 parenthesis, x over x divided by 100 to the 3, to the third power, so it's hat 3. And then go here times what? 1 minus x over 300. 300 to the 7 power, I think. So I'm going to plus enter to graph. And you see that straight horizontal line, right? And that's a problem. So what we're going to do is you're going to go to, on your TI-84, there's a window. But I hear it's not going to be window. So I hear it's going to be window here. And just set window setting between 0 to 300. So usually I have like some slack room. I don't use 0 to 300. I use X min, I use -10. And X max, I do maybe 350. Do you guys know how to do that? Just do window and then do that. And then you see a nice graph like this. And then you say, okay, well, that is net in. That's not including net out. So I'm going to go to create a new functions. So I'm going to do tab. I'm going to do vars. Wait, where's my vars? Where's the tab? And I'm gonna do tab. I'm gonna do var function 1. Now never ever graph integrals ever. So that's something that you don't want to do. So you can graph the derivative minus 0.7. Why is minus 0.7? Because that means is I'm gonna graph the in minus out. I'm not taking derivative. I'm taking the in minus out. I'm gonna get those two coordinates here. I'm gonna show you those two x-intercept. This when derivative equal to 0, which is when rate equal to 0. Not derivative, but when rate equal to 0. Not only anything, it's the net rate equal to 0. So if your net rate equal to 0, then you can say, okay, well, that's the point. So we gotta go find out where they intersect. This is actually a minimum, original graph. Does that make sense? Because it went from negative to positive. That's why it's a minimum. Does that make sense? So I'm going to do analysis the graph. I'm going to look at 0.
Before you go there, could you explain why it's f of x minus 0 minus 0.7?
Huh?
Could you explain why it's f of x minus 0?
Because the in rate minus out rate equal to 0. No, 0.7 t is the amount. 0.7 is the rate. So you want rate compared to rate. So you want R of t minus 0.7. Now what Jackie did was 0.7 t, but she didn't do it with the integral. Do you remember that? So because that's the rate. So now I'm going to graph this. I'm going to see this point here is 33, which is that's a point of interest. And I'm going to go to analyze the graph. I'm going to kind of not 0. So graph this part and I'll find another 0. So it'll be 167. You should get 33 and 167. Did you guys get that? That's the x-intercept. Now, which one's minimal? 33 or 167? 33. So what you want to find out is this. So you're going to go to calculate screen. You're going to say, hey, that's calculate. And I'm just going to do 20. Right. I'm just going to do here. I'm going to press enter. And you should get 3.803. Why? 20 people to begin with. Integral of in rate minus out rate. That means the net rate. Does that make sense? It's going to give you 3.84. So 33 is equal to 3.804. Why is that? Because of 20 plus integration between 0 to 33 of R of t minus out rate 0.7 dt. And that's equal to 4. Round up to 4. Round to nearest 4. Do I need to care about 167? Probably not, because that's a relative maximum. But just in case if I do, I'm gonna go do that. I'm gonna menu. I'm gonna go calculate. And I'm gonna do this one here. I'm gonna press enter. I should get 158. So 158 is not a point of interest. That's actually a relative minimum. So this is the lowest value here, which is 3.804 and cost 33 seconds. Does that make sense? Are we okay? Okay, we're gonna go look at the next question. Now this question I'm gonna do on the next video. So this is also a calculate question, but a velocity acceleration. I want you guys to give it a try. First question is pretty easy. Second question is pretty easy. Third question is pretty easy. The only question maybe kind of hard is D. But also this kind of question, you want to think about this question will including at time equal to 2 is speeding up or slowing down. Am I including finding average velocity from velocity equation? Am I including find the average acceleration? Am I including find the furthest right or left? They are part of the game. So you're gonna get any of those things. So that's something I will pay attention to. Okay, so on your homework, you might need to watch this video here to make sure you understand everything, but you should know how to do A to C with no problem. Now, this is the first time velocity equation has 2 particles. So I want to show you that they can possibly give you 2 particles. Usually it's 1 particle, but this is 2. Any questions? Okay, that should be all.